Alright, so we're going to simplify radicals. The previous example had just numbers in it, or the previous video. This video now has, we're going to introduce variables into simplifying radicals. So the idea here, again, is that we're going to use this multiplication property of radicals. Here's our multiplication property of radicals. And it says that if we've got a product in here, we can separate and conquer by separating this product, a times b, like 100, into 25 times 4. 25 would go in here, 4 would go in here, multiplication between them. That's what we're going to do with, we did that with numbers. We looked for perfect squares in the blue rectangle to rewrite our numbers. In the black, number 18, we rewrite 18 as 9 times 2, because 9 is a perfect square, and we can rewrite it as 3 outside the house. So we're going to do the same idea now with perfect squares in terms of variables. So what are our perfect squares in terms of variables? If I take x as my base and I square it, what do I get? Well, I got x squared. If I take x squared as my base and I square it, what do I get? X to the 4th power. If I take x cubed as my base and I square it, this would be my base, and I'm looking to square it inside the house, I would get x to the 3 times 2, 6th power. This would be x to the 8th power. This would be x to the 10th power. Because if I'm looking as my base outside the house, would be x to the 5th, my squared number inside the house would be x to the 10th. So we try to, and I'm going to put a dot, dot, dot down here because this will go on forever. But we're going to try and rewrite whatever's inside the house as these perfect squares. We're going to try and rewrite it as x squared times something else, x to the 4th times something else, x to the 6th times something else. Just like we did with perfect squares in terms of number. Square root of 18, we try to rewrite it as square root of 9 times 2, because 9 is a perfect square. When you separate and conquer, the 9 square root of 9 gets to be 3 outside the house. Square root of 2 stays inside the house. We're going to try and rewrite now in terms of perfect squares of variables. So let's take a look at something like this. If I've got, well, let's start with this, I guess. If I've got square root of x squared, I'm going to say that that is square root of, well, let's see, I'm looking for even numbers here to rewrite in terms of. So I got 2 as an even number already. All right, well, I'm going to rewrite as a base squared, because x to the 1st squared is x squared. So I'm going to rewrite that as a base squared. And when I take the square root of a perfect square, the base comes outside the house. I'm kind of rewriting over this stuff here, but we'll get this out of the way later. This is a parallel to the fact that we had something like square root of 9 is square root of 3 squared, and we know that square root of 9 is 3. But we say that we can rewrite 9 as 3 squared because now the square root of a perfect square means the base comes outside the house. And these are the same. Right here, this idea is the same as this idea. 3 squared is the base squared. X squared is the base of x squared, so that base comes outside the house. Let's now take a look at what we've got for x to the 7th. Alright, well, if I've got x to the 7th, I'm going to rewrite it as a perfect square. Perfect squares, remember, in terms of variables are x squared, x to the 4th, x to the 6th, dot, 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 with even powers. So x to the 7th is x to the 6th times x to the 1st. I'll rewrite it as that x to the 1st. Alright, so now x to the 7th is x to the 6th times x to the 1st, because when we multiply our same bases, we add up our exponents. Alright, now separate and conquer. Square root of x to the 6th goes over here. Square root of x to the 1st goes over here. I'll rewrite it as first, just to keep us in mind. Keep things in columns, it's helpful. X to the 6th is x to the 3rd squared. And all I do is rewrite x to the 6th as x to the 3rd squared. X to the 1st still stays inside the house, and he's not a perfect square. He's not going to come outside the house. He gets his own house. This guy gets to be simplified and says, just like up here, a base squared, square root of a perfect square means the base comes out of the house. Square root of a perfect square, base comes outside the house. Square root of a perfect square means the base comes outside the house. x cubed comes outside the house. House of square root. This guy is still not a perfect square. He gets to stay inside the house. And there's our answer. Square root of x to the fifth power. Well, let's see. We can rewrite this in terms of perfect square. Well, we're going to find that the perfect square is an even number, a base with an even numbered variable, an even numbered power. So we got to find the highest even numbered power here that can come out of the x to the fifth power. In other words, how do we rewrite x to the fifth in terms of an even power, and really x to the first left over? This would be x to the fourth times x to the first. X to the fifth can be rewritten as x to the fourth times x to the first. X to the fourth is an even power, so therefore this is a perfect square. I'm going to give x to the fourth its own house. I'm going to give x to the first its own house. This is not a perfect square. He's going to stay in there all the time. X to the fourth we can rewrite as x squared, because when we've got parentheses and powers inside and powers outside, we multiply those powers to get x to the fourth, or x to the fourth power. Square root of a perfect square means the base comes outside the house. X squared comes outside the house. And the square root of x to the first comes along for the ride because he's still inside the house. And there's our answer. We've simplified this as rewriting this x to the fifth as a perfect square times something else. Alright, one more. A to the 15th. Well, let's see. My trick is, if I'm looking for square roots, I'm going to have an a to the first power here, because we can't have an a to the squared power here because that squared would be equal to that index. We could pull that out as a perfect square. So we've got to leave an a to the first power. So what's left over? A to the 14th. That's the highest exponent, highest even exponent that we can rewrite that a to the 15th as. A to the 15th is a to the 14th times a to the first. Now a to the 14th gets its own house. A to the first gets its own house. That's a 14, by the way. All right. A to the 14th is going to be rewritten as a to the 7 squared. A to the first still stays inside the house over here. Square root of a perfect square means the base comes outside the house. That's a 7, by the way. A to the 7th power comes outside the house. Square root of a perfect square, base comes outside the house. A to the first here stays inside the house, and there's our answer. And all we've done is really just simplified all this stuff by rewriting as a perfect square. Here's a perfect square, it's got an even power. Here's a perfect square, even power. Here's a perfect square, it's got an even power. It's the highest even number that can be taken out of that x to the 7th, or that x to the 7th can be rewritten as x to the 5th is x to the 4th times x to the 1st, x to the a to the 15th, a to the 14th times a to the 1st. And then give everybody their own house, and then simplify from x to the 4th, x squared squared, a to the 14th, a to the 7th squared, x to the 6th, x to the 3rd squared. And then square root of a perfect square means the base comes outside the house. Square root of a perfect square means the base comes outside of the house. Square root of a perfect square, base comes out of the house. And we're done. And now this and this just adds one more level of complexity. And really, that's not that much. I'm going to do this one here. And this one I'll give you the answer to, and maybe you can kind of work on it. This one here, x squared y to the 5th, would be square root of x squared, square root of y to the 5th. That's a square root of. Separate and conquer. Give everybody their own house. Square root of a perfect square. All right, well, I guess I'll rewrite this as x to the first squared. Square root of a perfect square, base comes outside the house. I got x right there to the first power. Square root of y to the 5th is square root of y to the 4th, square root of y to the 4th times y, square root of y to the 4th, square root of y. Square root of y to the 4th is, well, we can go y squared squared. Square root of a perfect square means the base comes outside the house, y squared. And now this just kind of, well, it'd be square root of y, it'd be rewritten here, but you know what? I'm going to say that this just drops down to the bottom here, because that's not going to change. This is not going to change. So you can say, you know what, that's going to drop all the way to the bottom here. And that would be x to the first times y squared times square root of y. And all this stuff is multiplied together. You put it all outside the house. X, y squared, square root y, done. And all we've done is separate and conquer by giving the x's their own house, the y's their own house, and simplifying this. Remember, everything's multiplied together. Simplify this. Remember, everything's multiplied together. And at the very end, we multiply everything all together. Now, the next step would be to put a number in here and say, all right, well, maybe square root of 8. Square root of 8 would get its own house. Square root of 8 times all this stuff. Square root of 8 is square root of 4 times square root of 2. Square root of 4 is 2. 2 times the square root of 2. And that would be the really next step. All right, so let's get this one here. And I'm going to say, let's see, I'm going to put it in blue, I suppose. And I'll see if you can get that answer. That answer, I'm going to say, is going to be x to the fourth t to the fifth square root of x times t. And that's my answer. See if I'm correct. I'm pretty sure that is.